I'm Bob Detweiler. This is Mike Risch.
I'm Mike Risch.
We're the ones that worked on this machine and rebuilt it from the ground up. You're going to find that this machine is totally different, so I would suggest not thinking about anything you did in the past. Consider it as a brand new machine, new operations. We have a chart on the wall that spells out everything you need to do from A to Z. You follow step by step and you won't make any mistakes. If you try to interrupt those steps and put your own ideas in there, there's a possibility you could crash the machine. So I would just follow steps totally. And before we start talking about the machine, one thing I want to do is go over a couple things in Aspire, things that you need to look at before you ever come to the machine to make sure that you've got all your settings right and to get your XY0 in the right place. Now this machine did not have this before. It now has the XY0 over in the lower left hand corner. It's got the boards fixed on the top so that when you put your job piece over in that corner, that becomes your XY0. And when you program something, a lot of times you want to do it with the XY0 in the center, and that's fine. There's not a problem with that. Depending if it's a symmetric part that you're making or whatever. But when you're done doing your programming, before you go to the machining side, the CAM side, go back into your setup and change your XY0 to the lower left-hand corner. And you can do it in setup, but it's best just do it while you're right there. That way you won't forget it. Go on over to the machine side and start from there. Now I'm going to cover some things in Aspire here that you need to look at. I've got this program I want to bring up here. It's a little job that's already been written up. It's just a simple plaque, and it's a single bit. And we're going to do one with a single bit where we put it on the table. We're going to do another one where we do a multi-bit, which will be 2 bits, and we're going to put it on a sacrificial piece of wood that's going to be mounted to the table, so you can see how to mount both pieces on there and how to find your XY0. This machine will go back to XY0 every time it's turned on. So if somebody uses the machine and they change it, you don't have to worry about it anymore, because when you turn the power off, and every time you come in, even if somebody's been here running it, you should just go ahead and shut the power off and start from scratch, because they may put something in that offset you don't like, unintentionally, intentionally, whatever. Just shut the power off the machine, cycle everything down, and start from scratch if somebody's already been using it. If not, when you turn it on, it will put the XY0 over in that lower left-hand corner. You don't have to worry about it. This machine is calibrated to do that every time it's come on. That's something you didn't have before. You had to physically find your XY0. This one will be there. And anytime you're doing flat stock, the offset should always be number 1. You only use 6 when you're doing turning, so always check to make sure that your offset is set for number 1, because somebody could have changed it. And when it comes up, it could show a different offset, but the machine is actually going to go back to the lower left-hand corner. So make sure that the offset setting is set for 1. I can't emphasize that enough. But the machine will automatically go back there, so you don't have to change anything to get it to go there. I'm going to go to the drawing. First thing, we're going to talk about a couple things in the drawing. This is just a single bit drawing, and it's going to be a plaque, Kansas City Woodworkers Guild. And there, if you look here, if you go back here to the setup, when you're doing the setup up here, you go in here and this tells you whether it's in the lower left-hand corner or where your 0 is. This one's already in the lower left-hand corner, but I could have put it in the center. And then after I got all my programming done, I come back and put it in the lower left-hand corner. And when you leave there, if you've done any machining, it'll ask you if you want to recalculate. Say yes. But you shouldn't ask you that, because you should do this before we ever get to the machining side. So make sure it's in the lower left-hand corner. It makes life simple. You don't have to hunt around for it. You just put your board over there, clamp it down, you're ready to go. I'm going to go over here to the machining side. That's F12. It transfers it from the machine side over to the other side. And some things we want to look at, as on the screen up there, okay, is always go to the set. It's asking me to close it for whatever reason.
It's recording.
Okay, I'm going to go up here and I'm going to do an F12 and come over here to the machining side. First thing you should do is click on the set. When you go to the set, if you look up here at the top, it tells you the thickness of the wood. And this is very important because don't assume because it's 3/4 inch plywood, that's going to be 3/4 of an inch, because 3/4 plywood doesn't exist anymore. All the plywoods are different. Now this particular piece I've got here today happens to be 706. And so that's the thickness of the wood that we're dealing with today. So check your thickness. Now in this particular place, it's not going to make any difference because you're not cutting through. And since we're going to zero off the top of the wood, it doesn't make any difference how thick it is. But just get in the habit of always putting in the thickness of the wood. That way you don't have to think about, did I do it right or wrong? If you do it right every time, there's no second thoughts. So at first you go up here and you check the thickness, and then look to see that it's in the lower left-hand corner. Now, if for some reason you changed it, you can go back and change it to the lower left-hand corner at this point, but you should have already done it before you get to here. And go down and check your material position. You want that at the top. And most importantly is down here where it shows Z1 and Z2. Now these things here have not been used before because you didn't touch off on the top of the wood and do like you're doing now. We have a touch off to find the zero of the product that you're working on. And Aspire's default is 0.2 and 0.2. What that does is this says it's a rapid Z. The Z1, I set this for 1 1/4 inches. If you set there for 1 1/4 inches, what's going to happen is when it gets through cutting, say you're doing a rosette, you got 2 of them on this board. After it gets through cutting that rosette, it's going to pick up 1 1/4 inches and go across the piece of material that you've got for your job and go down and start cutting the next one. That rise is that Z1. That's the clearance above your clamps. So as long as you've got that 1 1/4 inches in there, you're not going to hit your clamps, because the way this machine is set up now, the most is ever going to be sticking over that piece of wood is maybe 1/4 inch. So you don't have to worry about hitting anything. So you leave that up at 1 1/4 inches, you got plenty of clearance. It goes over, goes down, starts doing its cutting. The Z2 is the distance that the bit travels from the bottom of its cut to the top of the cut within the rosette and moves over and goes back down again. And the Z1, when it goes across the table, it's going at a rapid speed. It'll go as fast as the machine will let it, which would be 100%. It'll go over there and it'll rapid speed down to that 0.2 that you got set for your Z2. And then from then on, it goes down at whatever feed rate you've got it set for, your plunge rate. So if you got your plunge set at 30, then it's going to rapid speed over to it, get down to the Z2, and it'll just slowly go down and start doing your cutting. So the purpose of that Z1 is to clear any clamps as it's moving across the table. If you have that up there, there'll be no such thing as hitting the clamps. And the clamp system we've got set up now is real simple. They're low profile. They're not going to ever give you a problem. It'll hold the product into place every time. The next thing to look at down here, and this is something I know people don't use, and don't let it scare you. I've been told that that's probably going to scare some guys, but if you're confident in the machine and what you've done, it's not going to bother you. There's down here where it says home and start position, you got your X and your Y. Now the purpose of this is to start and stop the job at this point. So if you put a piece of wood on there that say it's 6 by 12 like we've got right here, what I've done is in the X I put 16, which is 4 inches more than it is wide, and in the Y I put 10 inches, which is 4 inches more than it is high. And so when that product goes to be cut, it will go over to that location, come back, start cutting your product out. And when it's done, and you're done cutting, instead of the machine just going to XY0 and stopping, now it's in the way. Now you have to reach over and you have to get the mouse, the trackball, and you move the gantry out of the way in order to take the piece of wood off of the machine. Well, if you do it this way, it'll move itself out of the way, because when it's done cutting, now it'll move out in the X position and the Y position, whatever you have this set in. In this case, it's going to move X 16 inches, Y 10 inches. It's going to move the gantry up and out of the way so you can take your board off of there and you're not interfered by the gantry being in your way. It'll make life a whole lot easier. Just don't get scared when you turn the machine on and it comes over and finds your XY0 and it starts heading across the table and you think, oh my God, what's it going to do? Cut over there somewhere? It'll stop and it'll come back. And it'll start at the elevation you've got that set for and dive down to whatever it takes to get to that board and start cutting. So just keep in mind that if you set these at 3, 4 inches or 6 inches past whatever your X and Y is, it will get the machine out of the way when you're done cutting. And it'll make life a whole lot easier. You won't have to think about it. And if you're done working with the machine, you take your part off of there, start shutting everything down, clean it up, and just leave it where it's at. And then the next time a person comes in and references the machine, then it'll start up and everything will work fine. I just want to show you a few things in Aspire that you need to look at when you're done doing your programming and you start setting up the final steps before you create your G code. And these things will make a big difference in how fast you can do your job, because you won't be sitting there trying to run the machine around to get it out of your way, which you have to move it anyhow because you can't get the wrenches in there. So you just move the gantry over with your program, let it do the work for you. Then you just reach over and take your bit out. This machine's so small, if it goes another 4 inches, it's not like you can't reach it. Take your bit out, take your product out, you're done. Clean up the machine, you're ready for the next guy. When you want.
Okay. Go.
Okay. Okay, we're coming in the machine room. First thing we're going to do is turn the machine on. Before you do anything else, turn the machine on. It needs to be turned on, sitting there running by itself. There's a green light right up here on the top that tells you if it's got power. This green light down here is surge protection. That light is always on, no matter what, whether the machine's on or off. That light's on, saying we've got protected power going into the machine. So that light will be on. Unless somebody's unplugged the machine, it will be on. The green light up here on the side of the gantry tells us that we have power to the machine because we turned the machine power on. Next thing we're going to do is we've got a list on the wall here. You'll get familiar with it after a while. You won't need to look at it much, if at all. Turn on the power to the machine first thing. Next thing you're going to do, and we already have it on now, is turn on the monitor. Let the monitor come up. When you turn the monitor on, it's going to have the Windows sign up there. Next thing you do is turn on the computer. Got a little button right here on the side. Push this button to turn it on. When you turn the computer off, always turn it off like normal Windows shutdown. Okay. Once you've turned the computer on and it's up and running, and you know that you're going to cut something in here, you have to say, well, do I have it already on the computer, or do I have to add it? And if you have to add it, take your flash drive, put the flash drive over here, one of the plugs, plug that in. We're not going to run any programs off the computer, off the flash drive by itself. It's going to all be run off the computer. Where's the mouse? Oh, wrong one. Okay, on the screen up here, there's a shortcut up here that goes to the USB hub. You click on that, and right in there, there's mine right there. I got the KCWD demo, and I'm gonna put that folder into the computer on the machine. And I know that I don't have my name in there yet, so the first thing I have to do is create a file in here. So you come over here to KCWG, click on this, and there's where your name's going to go. So in this case, I'll come down here and create a new folder. Come down here, new. I'm sure everybody knows how to do this. New folder. After you create your folder, that's where you're going to put your files from your flash drives into that folder. Okay, come over here, click on this shortcut, go in here, pick up the files that you're going to put on the machine. Today we're going to put 2 or 3 of them on there. So I'm going to pick on 2 or 3 files to transfer them over there. I'm going to pick on the turning demo, which we're going to do a turning demo. Pick on that one. We're going to pick on text document for a multi-bit. And we're going to pick on one for a single bit text document. That's all you need. Now I have drawings in here. I have job sheets in here. We don't want to put any of those on this machine because they serve no purpose whatsoever. The only thing that should be put on this computer is strictly just your G-code, just your text files, and that's it. Copy these files. Close your flash drive. There, come over here, open up your folder on the computer, come down and find your name in there.
Be right there at the top.
Mine happen to be at the top. Double click on that and paste your files in there. Now I've got 3 text documents in there. I've got my turning demo, I got a multi-bit, and I got a single bit. That's the 3 jobs we're going to do today. So that's all you have to do as far as getting your files in there. That's it. Don't put any drawings, no text, no job sheets, any of that, because it serves no purpose here whatsoever. And this screen should only have those 3 items on there. One is the members list, one is a shortcut that goes to the flash drive, and the Mach 3 loader. After you've got that on there, pull your flash drive out before you do anything else. Pull that flash drive out of there. And if you look at this list up here, it tells you, remove the flash drive before starting Mach 3. Don't start Mach 3 and then pull your flash drive out, because there are times that when you do that, it will crash. So just pull the flash drive out of there and you're done. You've done everything that you need to do. We're going to go on down the list. Next thing you would do is we come up here and we open Mach 3. Okay, next thing it says make sure the soft limit light is on. There's a soft limit light over here, and you have to make sure that light's on. Right down there at the bottom. There's going to be 2 lights you want to have on. Soft limit light and the dust shoe. So make sure that soft limit light is on, and then click the red flashing reset button up here. And what's going to happen is this machine is going to reference a machine. You've never had this before. What it's going to do is it's going to go out and find the extreme distance that this machine can operate at. And this machine will automatically find X, Y, and Z locations. So when you do that reset, the first thing that's going to come up after you do that is going to say, do you want to reference the machine? Say yes. As soon as you say yes, then that machine is going to take off and start going wherever it needs to go. It does the Z first, then it's going to do the Y, and then it'll do the X. Machine's moving now and it's moving to its destination. It's got sensors in there that's been calibrated that knows exactly where it has to go start and stop from. V-bit. Okay, next thing is after you reference the machine, the first job tool is put into the spindle. Now we're going to do a warm-up. And you should have your job sheet already printed out for you, so when you come in, you know what bits you're going to use, how many, whether it's going to be a single or whatever. But take that bit and put it in the spindle before you do the warm-up, because if you try to warm it up with just the nut on the spindle and the nut is loose, when the spindle shuts down, it'll spin that nut off there. It'll be like a top. It'll be going all over the table and bouncing on the floor and go everywhere. So it needs to have something in there to keep it from spinning that nut off of there. And since you know what bit you're going to use, now's the time to put it in there, because you're going to put it in there sooner or later. So you might as well just do it now and kill 2 birds with 1 stone. So we're going to take this bit and we're going to put it in the collar right now. Wrenches. Make sure you have the right size collet in there. This bit I'm using is a 1/2 inch V bit. 1/2 inch shank V bit. It's a 1 inch bit, but it's 1/2 inch shank. You got 2 wrenches. Don't try to over tighten this, just snug, and that's all you need to do. And when you put the wrench on the spindle to hold it, and you're going to tighten the nut up, do not take this wrench here and put on it and push on it like you're going to tighten the nut, because what's going to happen is you're going to override the power of these stepper motors. And when you do that, if you move that stepper motor back, you've just lost all of your calibration, because now you've changed the number of steps. These stepper motors have 3,200 steps in one rotation of its shaft. That's how accurate it is. So it moves like 0.1127 of 1 degree. And if you move that stepper motor back, you could have lost several degrees right there. And now if you start cutting your product, it's going to be wrong. It's not going to be what you think it is. Because the computer says, I want you to do this, and it thinks it's somewhere else. So whatever you do, don't put this second wrench on here and push against the machine. Put the wrenches in your hand and pull against your hand itself. Put the wrench on there, get it in position, take your hands and just squeeze this with your fingers like this. Just good and solid, that's it. That's all you need to do. You don't need to get on there and really crank it tight. It doesn't take that much to hold it. Okay, next thing it's asking you up here, you want to reference the machine, or do you want to warm up the machine? Say yes. I want to warm up the machine next. So you click on the button up here, it says warm up the machine. Say yes. That's going to come over and ask you for a bit. You've already put it in there. You could have put it in when I did, or you can wait till it comes there. But put the bit in there and let it warm up with the bit. Now if the bit is bigger than 1.25 inches in diameter, you cannot do that, because the bit can't handle that speed, because this goes up to 21,000 RPM during the warm-up. Some bits can, but we don't recommend warming up a bit at 21,000 RPM for 1.25 inches, bigger than 1.25 inch bit. Most of your bits are all going to be less than that, so it's not a concern, but just think about that. If for some reason you use a big bit in there that's going to, be over 1.25 inches. This one here, it's just a 1 inch, it's no big deal. Come up here, click on there after you've got the bit in it, you know it's tight, say okay. It's going to go back, it's going to start warming up the machine. Every time that machine comes on, the spindle starts, you're going to hear a little beep. And what that is that's proving water flow through the spindle to make sure we have flow for cooling. If that's continuous beep, don't go any further, because there's something wrong. You're not getting flow through the spindle. There's no way to turn it off, so if it's there, just remember there's a problem. You should not have a problem, I just mentioned that. Every time the spindle starts, you're going to hear this little beep. That's normal, that's okay. That's saying that we're establishing water flow through the spindle. It takes about 4 minutes for this spindle to go through a warm-up. If you come into this room and you don't know 100% that somebody has warmed this up, you warm the spindle up. Don't assume that somebody's done it, because somebody said, well, I'm going to be here at 9 o'clock in the morning and I'm going to use the machine, and they didn't come, and you come at 1 o'clock and say, well, Tom was going to be here this morning at 9, so I don't have to worry about it. No. Unless you were here and you know for a fact that he used the machine, you warm it up. Because warming it up is the life of that spindle. If you start cutting and you haven't warmed it up, those bearings are not going to last very long. Okay, now the spindle's warmed up, you're ready to go from here. Next thing you're going to do is you're going to put the dust chute light, turn that dust chute light on. Well, first you say click OK up here. You know that the spindle's warmed it up. When you do that, the constant velocity light will come on, soft limited lights will come on, it'll be off, it'll come on, and if the dust chute is not on, turn it on. But don't put the dust chute on there, just turn it on, because when you do a cycle start and you start to cut your product, it'll come up and tell you to install the dust chute. So just don't put it on at this point. Next thing we're going to do is we're going to put our product in here, and it's going to be, in this particular case, it's going to be a single cut. We're not cutting through, so we're going to mount it on the machine table here. Drive the machine out of your way, and we're going to mount this board on here. Now this machine XY0 is over here. If you want to verify that the XY0 is over here, there's one way to do this. Go up here to your Z axis and make sure that it's up high like it is now, and zero the Z out. Absolutely make it zero the Z out. If you don't, you could crash the machine. After you zero the Z out, then you come down here and say go to offset. Make sure you're in offset number 1. You're doing flat work, not turning. Go to offset down here where it says go to offset, and you click on that. It's going to come over here and it's going to go where the machine thinks that XY0 is. In this case, we know it's going to be in this corner. You can, if you're not sure, you can put the laser in here. We have a laser, and it'll line up right on this corner. Now we're going to talk about the laser down the road here in a little bit, how to use the laser. We've got the V-bit in there, we know that it's right there in the corner, it's okay. And we'll put the laser on and show you how to use the laser and the calibration blocks. But for right now, we're not going to do that. Not going to use any big clamps anymore. Everything is going to be low profile. The XY is right here in this corner, and they have clamps on both the X. And why. Now we know that the program is set up for X, Y in the lower left-hand corner, which is right here. So take your board, put it on there, and pull it up. Now we've got these little clamps right here. Pull these clamps down here, and if you loosen them up, they'll go out over the board about 1/8 of an inch. Pull those out, pull this back in the corner, tight against the corner, and tighten these down. Put as many on there as you want. We got 3 on each side. Something this big, you don't need a couple on each side. But put it in here, pull it back, tighten this one down, put another one on here, tighten this one down. Now it's down pretty tight. The only other thing to do is we're going to have some low pro clamps from Legacy. We don't have them yet, but as soon as they become available, we're going to get them. They're on back order right now. We've got these Veritas clamps. They work pretty good. They're not as convenient as the Legacy clamps, but they do work. They're a cam lock type clamp. Get it in there. The Legacy ones are much easier to operate. These are kind of mousetrap type thing. Okay, bring this down. Where's that piece of wood? I have a piece of 1/4 inch wood here the other day that we need to use. Gary, do you know what happened to that piece of wood? Here it is. You got it with the 1/4 off? Okay. Okay. These clamps, these Veritas clamps, they need a 1/4 inch clearance in here to work right. So put it up here. Put the clamp all the way relaxed. Put this 1/4 inch board between your clamp and the wood. Take a T-handle wrench. Tighten this down to the table. Pushing against the clamp and up against that wood. Once you do that, you pull that out. Now you take this cam lock and you go on around and you tighten that up against there. That holds it up against these stops. Put 2 of those on there. Put your second piece of wood in there. Same thing, relax the clamp. Tighten it down to the table. Pull it up as tight as you can. Tighten this down. Pull this out. Bring your cam around. Tighten him up. Now it's locked tight against it. It can't go that direction because the clamps are coming from it. No matter how much pressure you put down on something, you can put hundreds of pounds, you can't overcome the torque to keep it from getting moved. So we put these other clamps in here, the wooden ones, and you pull it up, unscrew this, put it up on top of the wood, tighten this down, hold it back against your Y-axis over here, tighten this down. Now that not only pulls the wood down, but it keeps it from ever getting pushed the other direction. Now you got all your clamps in here, everything's tight, you're ready to go. That's for flat stock. Next thing we're going to do is we got to do a touch off. We have to know where the top of this wood is. This is something you've never done before.
Reset lights flashing.
I don't know why that light's flashing. Okay. We're going to move the spindle down over the material we're going to be working on. Find a spot in there anywhere, it doesn't make any difference. And we're going to take this touch pad. We're going to set this touch pad underneath your bit. The next thing you're going to do is you're going to come up here and where it says Smart Tool Setup, you're going to click on Smart Tool Setup. It's going to come up, it's going to ask you, do you have the bit over the pad? And say yes. Okay? The next thing you're going to say, are you going to use multiple bits? In this case, we're not going to use the one bit, so we say no. As soon as we do that, it's going to start zeroing out the wood. Hold down on the block, so make sure it's tight against your wood. It's going to come down once, back off, come down the second time, touch off. Now it's zeroed out. Take this touchpad and put it over here on the bench, right there on the, it's got magnets on the back. It won't fall off on the floor. Now what you've done is you established your Z0 for the top of the wood. And like I said earlier, on a single bit, you're not cutting through. It doesn't make that much difference how thick it is, but you should get in the habit of putting your drawing how thick the piece of wood is. If you're going to do more than one bit and you're going to cut through, absolutely make sure that you put the thickness of this wood into your drawing, because if you don't, and you put 10,000ths of an inch in, and the board is 30,000ths of an inch thinner than what you think it is, you're going to cut into more than what you want to. We are going to have a sacrificial piece on there, but still, you need to get the habit of doing that. Okay. We found our XY0. We've touched the pad. We know that we've got that right. If you don't do any of this, you foul up and you cut that tabletop and you chew it up, you just made a $175 mistake, because that's what it's going to cost to replace it. So think about all the steps that you're doing. We put the touchpad back where it belongs. It will automatically go wherever it needs to go after it's done. If you're doing a multiple tool touch off, which will show you it's going to go in a different position, but on a single bit, that's where it's going to stop, is right there. Next thing you want to do is load the code. So I'm going to come up here and I'm going to load the code. I'm going to go up here to my folder. Pull this down. Find Kansas City Woodworkers Guild. Member projects, and find my name on there, wherever it's at. It's got to go down lower. No. Should be right there at the top. There it is, right there at the very top. It was down a little bit already. Click on my folder. After I've clicked on my folder, next thing I'm going to do is I'm going to pick the program I'm going to run. Now this is a single bit, so I'm going to pick on the single bit, click on that, come down and say open. Now it comes up, loads the program, and up in the window up there where it says status, it says VCarve 1. It's going to do a VCarve, and you don't have to know what bit it is because it's going to tell you, but you should already have a bit in there, because if you got a job sheet, you know that you're going to be using the V bit. Next thing I want to do is go up here and I'm going to do a cycle start. But before you do that, you need to make sure that the vacuum system is turned on to this room. I guess they're going to have a remote control in there so you can do it remotely in here, but make sure you turn your vacuum on, because you got to have the dust collector running. You want to turn the dust collector on, somebody?
Where's it at?
Right the other side of that wall.
She's got it. Okay, you got the vacuum turned on. Now you're ready to start. Do a cycle start. Now it's come over here, it's going to ask you for the bit. You should already have your bit in there, because that's the first thing you did before you did a warm-up, because you knew that you're going to use a V-bit for the first thing. So if you do that ahead of time, you save yourself a lot of steps down the road. Okay, we've got it in there. Next thing it says is click OK and press the enter button. So I click OK. Next thing it says is to make sure you get the dust shoe on. So at this time you put the dust shoe on. You have the light on already, but you don't put the dust shoe on there until it tells you to. That way it's not in your way when you go to put bits in, when you go to do the warm-up, any of that, it's not in your way. You just snap it on there. It's magnetic. It'll stay on there. Once you've done that, once you say OK after you put the dust shoe on, it's going to take off and start running. And I want you to watch this location where this bit goes. Took off way off the other side of the table and comes back. That's because we programmed it to end up there when it's all done. Okay, now you see what happened. It moved the gantry out of your way so you can take the product off of there without it being in your way. And when you go to pull this dust shoe off of there, make sure that bit is stopped completely, because it'll turn several times and you can reach in there and pull the dust shoe off, you're going to cut your fingers off. So always look underneath and make sure the bit is totally stopped before you take that dust shoe off. Then you can take the dust shoe off, take the bit out, do whatever you're going to do, and you're done with your product. That ends up finishing up your job for the single bit mounted on the table. The next thing we'll do is we'll do a multi-bit, show you how it touches off and how it works. Since I'm going to have the boards going to be the same size, I don't need to worry about moving those clamps. If I had something bigger, then I have to move them. But there's what you get. And you can see where the spindle ended up with when you're done.
Okay.
This machine has a laser. It's a powered laser. It gets its power from out of the machine. There's no batteries to mess with. We're going to put the laser in there. I'll show you how this works, and also how you use these calibration blocks. Vacuum for a little bit. This laser takes a 1/2 inch collet, just like the 1/2 inch bits. Do not tighten the laser in the wrenches. You don't need to have it that tight. Put the laser in the collet, tighten it up just hand tight, squeeze that hand tight. Take this plug, and there's a jack up here on the machine. You plug that in. That turns on the laser. Okay. We can check the XY0 real easy. If you're not sure that it's a 0, if you want to just verify that it is. Get the clamps out of our way. Most important thing is always make sure that your Z is up as high as you can get it, so that it doesn't hit on anything when it starts moving. Okay, once you've got it up there as high as it'll go, hit the Z and zero it out. You've got to make sure you zero it out. If you don't, that's going to drive down and it's going to tear up the laser.
Watch the cord.
Yeah, and you have to watch the cord when you move this thing around too. You have to kind of think about what's going on here, because the cord's got to go with it. Okay, then come up here. If you want to just double check to make sure that you've got your offset where you think it is. Hang on to the cord, hit the go to offset. It'll come over here. If you look right here, I don't know if you can see it with the camera, that X on the crosshair is right there on the corner. This block sits over here in the corner. You have to move the clamps out of the way. You slide this block over here in this corner, and you set the crosshair, and it'll line up dead on those pencil marks that's on this block. That'll tell you that it's dead zero right in that corner. When you go to tighten it, tighten against your own hands, not against anything else. Take your fingers, push against your own hands. It doesn't take that much. Just snug that down. That's it. Don't push on it trying to do it like this, because you're going to move the gantry and then you've lost your calibration. I know in the past you didn't have to deal with that, but this machine is now calibrated every time it comes on, and it remembers where all these spots are at. And if you do something like moving it when it's not supposed to be, you change your calibration. Okay. I'm going to move this over out of the way. We're going to go to a multi-bit cut. And it's the same thing as a single bit as far as setup. Go through all your basic machine setup first. Go through your warm up, do whatever you've got to do to get to this point. Then we're gonna put our sacrificial piece in here that's gonna hold this block. And I'll have to get the wood and get, that's not it, we have to put a sacrificial piece. You can go ahead and shut the camera off, we got to drill it. For the double bit, this is going to get cut out. I know that this one's the right thickness because I've already measured with my micrometer before I put it on here and did the program. Pull this up in this corner. We're going to use 4 Craig screws, 1.25 inches. Drop in each one of these. Square drive. They'll go into the wood 1/2 inch, which is plenty. This is Baltic birch, it holds really good. Just run these in there, just snug it down a little bit, that's all you need. Make sure though when you're doing this, you got it back in the corner over here. Which it is, it's tight against this corner. Okay, now the reason why it needs to be tight in this corner is because these boards on here, these stops on this sacrificial board are parallel with the machine. So the X and Y on this board up here is running the same dimension as what it is on the top. So X is right in line with X, Y is in line with Y. It's a square corner, it's 100% square. So put your piece on there, square that down. Now the next thing you got to do, you got to find out where your XY0 is. Let me have that drill back. I got ahead of myself here a little bit. But we have an outside corner here. Well, I didn't quite clear the screw. We have to find out where XY0 is at because now it's been changed. It's no longer back here. It's up here. So we got to create a new XY0. So this is the block that you put on there for an outside corner, right there. That will tell us when the laser's on there that that right there is your XY0 of whatever you're cutting. No guesswork. There again, if you're going to do this double bit and you haven't done anything else, make sure you go through the startup procedures, warm the machine up if it has been warmed up. Put the laser in there, plug it in. And there's not a lot of clearance, so you have to make sure you get this up all the way because it's just barely going to clear. And I'm not so sure it will, but I think it will. Yep, it'll clear. Okay, now you're going to keep driving this back and forth until you get those crosshairs of the laser lined up with the crosshairs on that block. Go to step jog, 10 thousandths. And with this trackball, you're going to get, a lot of you are not going to like it because you've been so used to a mouse over the years, but this thing is so handy because you can put it in your hands and you get right down here. Once you put the cursor on whichever direction you want to go, take your thumb off the ball. From then on, all you have to do is touch the button and you get right down here at it and click on it a time or two until you get it zeroed out. Move it to the other one, get over there. Okay, we're right on XY0 on the corner. That tells us that we're on the XY0 on this piece of wood. So we know that's accurate. Unplug the laser. We'll have to move it out of the way because
That is 0 X and Y.
yep, you got to zero the X and Y, which I did not do that. So I have to do this over again. I got in a hurry, didn't push the X, Y, 0. If you don't do that, it's going to go back where it was originally, which is not good. So make sure when you set your X and Y like I did that you hit the X, Y, 0. I don't claim to be a teacher. Okay. We're gonna run it back up there again. I only moved the Y, so I don't have to mess with the X. I know it's right. In thousands, step jog. Right there. Now I go up here, I zero out X, I zero out Y. That's the new XY0 right there. Now I'm ready to unplug this, move it back, put the bit in. Yep, and don't let the cord get in the machine like I just did. Hang on to the cord all the time. Okay, take the laser out, pull that down, put the drawer, put the bit in. Tighten the bit up, hand against hand. Takes care of that. Take your block out of the way, move in. I have to put the screw back in that I took out to put the laser on there. Okay. Next thing we have to do is we have to find our Z height right here, and we're gonna do a touch off here. So we move our bit over the wood somewhere. Doesn't make a difference where. It's about in the center somewhere. Bring it back, and then set your touch off pad under the bit, and go over to where it says Smart Tool Setup. Click on that. It's going to say, are you over the pad? Say yes. Now here it's going to say, are you doing more than one bit? Say yes. It says, are you positioned with doing it with multiple tools? Say yes. Hold the pad down. Then touch off once. Comes back down the second time. Touch off. It's going to go up and stop. Now, put this pad back over here on the desk, and up here now it says, move the Smart Tool to its home position. All the other machines that Legacy builds, you move that Smart Pad over to a little metal pad that's up here, but since we have a turning center, we couldn't do it on this machine. So we've put a touch pad on the machine itself. That's going to be the secondary touch off. So it says move to home position. All you have to do is put the pad on the bench. You're done. Click OK. Now it's going to come over, it's going to touch off again. What that's doing is telling the machine what the height of that material is for any future bits, because when you go to put another bit in there, it's going to go over and touch off on there. You don't have to use the touchpad anymore. Okay, it's touched off. Now it knows where the height of this bit is and any future bits, because when you put another bit in there and you tells you to touch off, it'll go back over to there. Okay, going down the list. You got a list on the wall here, step by step what to do. Same things we did before. We touched off, we did our touch off. Make sure that you've got the wood in position, you got the right thickness, you got all your, think about all your settings, make sure they're right so you don't cut through the top. If you use multiple tools, say yes. If not, say no. In this case, we said yes. It went over and touched off on the bench, on the tabletop, that it did not do on the other one. The only time it comes over and touches off on this one is if you're using multiple bits. If you're using a single bit, it only touches off on the pad only. Okay, the next thing you do is load the code. Now, if you're gonna make more than one part, don't run a part and then turn around and run it again off the same code that you had loaded in there. Close the code and reload it again. It should work every time, but there are times that it doesn't. And I know from experience that I've made several parts and make 3 or 4 of them and everything's working fine. You go to the 5th one, then all of a sudden it goes off and starts doing something totally different. We don't know why it does that. It's just something in Mach 3 every now and then does that. So every time you make another part, if they're all identical, just close the code and reload it again. Now in this case, we're going to load the code. This is going to be a multiple bit one. And we've got it up here on the chart. It says multi-bit. So I'm going to click on the multi-bit and I'm going to say open. Now if you notice in the status line it says cutout. Well, for whatever reason it puts the last bit that it's going to do in there. Instead of the first it puts the last. It won't show you the first bit until you do a cycle start. So once you get to this point, you've loaded your code, then you do a cycle start. And you don't put the dust shoe or anything on it yet, because it's going to tell you when to put the dust shoe on. That's only going to happen after you do a cycle start. Okay, we've loaded the code. We've got the code in there. We're ready to do a cycle start. Come up here, hit cycle start. It comes over asking for the bit. Now we knew what bit we were going to have by our job sheet. We already put the V bit in there. It's asking for a 9-degree V bit, 1 inch. It's already in there. Once you do that, you say, okay, I've got the bit in there. I'm ready to go. It's going to come over. It's going to touch off. Now you notice when you did a single bit, it didn't do that because it just had one bit and knew where it was at. Now it's touching off for multiple bits. At that time, if you look up here on the screen, there's a smart tool light that came on. When that light's on, that tells you that you're going to have more than one bit in the program. If the light's off, you're only going to have the one bit. So anytime it does multiple bits, it turns this light on for you. It tells you you've got a smart tool set up. You're going to use more than one bit. Okay. Next thing it says to put the dust shoe on. So we touched off on the bit. We loaded the code. We're ready to go. Next thing we're going to do is say yes. We've got the dust shoe on there. I don't know if I put the other straight positions on there or not. I think I did. Yeah. Okay, it's going out away from your board, coming back. Heads out the other direction, don't worry about it. Now you notice the machine came up here, it didn't go back like it did before on the single bit because it knows there's other bits to be used. So it's time to put in your second bit, make sure that spindle stopped before you reach up and take the dust shoe off. Take that bit out and put in your next bit. In this case, the bit's going to be a 1/4 inch, so I have to change the collet. Tighten the collet up, hand against hand. Don't need to really over torque it that much, just good and tight. That's set?
No,
Well, it'll do a touch off. You don't need to put the dust shoe on yet. Say okay. It's going to go over and touch off where it originally went for multiple bits. Okay. Just ask me to put the dust shoe on. Put the dust shoe on there. Say okay. It's going to start cutting this out. Okay. Spindle stopped. Turn the vacuum off. Take the dust shoe off. Pull the part off of there. As you can see it cut through there. You just cut a little bit into the wood, not very much. This wood was .706. I set it for .716, 10 thousandths of an inch. That's all deeper you need to go. 5 to 10 thousandths is plenty. 5 thousandths is enough. As you can see, it cut out everything except where the tabs are at. And it didn't hardly cut anything into the sacrificial material at all, just kind of skimmed along there. This board lasts a long time if you only cut in 5 thousandths, 10 thousandths at a time. 5 thousandths is really enough. But you have to know how thick this piece of wood is before you ever put it on the machine. So when you make a drawing, have the wood ahead of time so you can measure that piece of wood. And if you have to, mark on the back piece of wood, this is for so-and-so project, and mark the thickness on there. So when you come to the machine, you know you got the right piece and it's set up for your particular job. Because if I had said this was 3/4 inch plywood, which is what they call it, and this is only 706, and I added another 10 thousandths to it, that thing had been cut way down at this top because this is .706, so it had been cutting in there a whole lot, 50, 60 thousandths deeper than it should. So you'd have a 60 thousandths of an inch cut in there. The way it is now, I only cut in about 10 thousandths, and that's it, and that's plenty.
Show the camera. There we go.